So good morning guys, welcome to the new session of Openstack. So last week unfortunately session was not recorded because there is some change in the GeoMeet policy, so I'm not able to record and download. So that I'm trying to see how I can manage, but I'll just try to repeat what we discussed in the previous session in the last class. So if you remember in the previous class I mentioned you about the OpenStack software, that this particular OpenStack software, where do we actually deploy and how does it transform your physical data center into a virtual data center. So if you see this green color layer, which is basically your OpenStack software which you deploy on top of your physical servers. Now here you can see that we have physical server, then we have the switches, switch 1 and switch 2. You can have more number of switches also if you want to have high availability. Like if you want to have extra high availability, then you can obviously have more number of switches. And then comes the actual thing, that is your storage. So the storage which you see here is your physical storage, and because you are going to create a data center, a virtual data center, the capacity of that virtual data center should be very huge, because it is going to offer services to n number of VMs. Therefore, this data center, the physical storage capacity should be huge one. So you can connect different storages. On top of your storage, you can install some free open source software. As I mentioned, like Ceph. Ceph is one of the open source software which is used to provide use services. What are the services? File services, storage as a file, storage as a block service, and storage as an object service. So three type of services usually we get from storage, any type of storage. So it's not like only about OpenStack or any cloud, but the basic storage is three type of services we get. One is block storage, another is your object, and third one is your file storage. So you need to have some physical storage in your data center. That physical storage, on top of it you can install some Ceph storage, Ceph software, and then you can connect that particular storage with your OpenStack environment. Now OpenStack, as I mentioned, is a software. So this software you are installing in your physical servers depending on the different type of roles. And then internally, on low level, you see these hardware devices like switch, storage, they are connected to your physical server, and then everything is going to be provided to the end users via this OpenStack software. So let's see. First thing I mentioned was the Lifecycle Manager. So the very first role which we usually provide to any physical server is the Lifecycle Manager. This is as per the OpenStack OO deployment architecture, suitable for commercial usage. So any type of commercial or production system, if you are trying to deploy, the very first thing we usually deploy is the Lifecycle Manager. So this Lifecycle Manager under OO concept is called as the OpenStack over OpenStack. So this is first OpenStack software. So don't get confused with the word OpenStack over OpenStack. You simply assume this is your director node, because Red Hat call it as director node. In generic terms, we call it as undercloud, and then the whole setup is known as overcloud. So this particular physical server one, we call it as undercloud, and then the next all the consecutive servers we call it as overcloud. Red Hat call it as director node. Then these nodes overcloud. What exactly is overcloud? Divided in two parts. One is your controller and next is your compute. So controller means which is going to control your OpenStack architecture, which is going to take care, or which is going to be involved in your day-to-day operational activities of your OpenStack, like managing the cluster, managing the host where you are launching your VMs. Then comes your worker node. So let me go one by one. So OpenStack controller node, which is going to control your architecture. Then you have your compute node. Compute nodes are basically the physical servers on top of which you run your virtual machine. So what happens in OpenStack? OpenStack offers you virtualization. Virtualization means you can launch VM on top of OpenStack. So the moment you launch virtual machine, definitely it gets launched somewhere in any of the physical host, depending like how the process has selected which host was suitable for your need, and based on that it has selected some of the host, and then on that particular host your VM is going to be launched. So it is same concept which was there in your older virtualization. So if you see your older virtualization concept, where you can do virtualization in your single hardware. So in your single hardware means you have one single hardware, you install hypervisor, and then after that hypervisor you can create n number of VM in that particular physical server. But only thing was that who is going to manage the life cycle? For example, if your VM is deleted, then who is going to bring it up? Who is going to migrate your VM from one physical host to second VM host in case of any problem in this physical node? So that task was given to OpenStack. So OpenStack is actually a collection of software, so it has different functionality. The very basic functionality of OpenStack is that it is offering you virtualization, means you can launch virtual machine with the help of OpenStack. So the virtualization hypervisor, everything is same what you studied in your VMware or your KVM or any type of virtualization technology. The basic engine remains same. Only thing is that it is providing you some kind of an management, controlling of those VMs. So you can see this is a particular, you can see these are the particular zone. So let me change my mouse pointer. Yeah, so you can see this is the particular zone. So let me go here. So see, this is the zone where your VMs are actually getting launched. So this particular host is having VM, and then that VM is connected to your storage. If you need storage, it is connected to storage, and then it is connected to switches for external communication. So everything on your VM, if you are a user, so if you want to understand that if I deploy a VM in OpenStack and how my VM is placed in that whole OpenStack data center, so this is the view. On top level, if you see from top level, so from top level you will see that your VM is getting deployed in the OpenStack dashboard. From OpenStack dashboard you can see your VM state, your VM, you can do all the management tasks, like you can bring your VM down, you can reboot, or you can delete, you can create a new VM. All those things you can do from OpenStack GUI or from CLI also, if you want to integrate your third-party tools for doing this task automatically. If you have some framework like Terraform, so with the help of your Terraform framework you can automatically create your VMs. Now all these things you see is happening in this area, in this physical server 3, starting from 3 till n. But these two nodes are not involved in your, as a user you don't even understand that even these two exist or not, because you are always connecting to the some GUI IP and then you are doing all the tasks. So the IP which you connect is actually your controller IP, but controller IP is exposed via HA proxy. So you have a proxy, you can have one means controller, you can have 3 controllers, you can have 4, 5, 6 n number of controller. This depending on the what type of resilient network you want to design. So if you want to have a highly resilient, that okay, in case of 1 point of failure or 2 point of failure or 3 point of failure, I want to have n number of controllers, so you can have n number of controllers. N number means definitely it should be some like 1, 2, 3, 4, 5, 6, 7. The maximum controller you can assign to any structure I think is 17 or 16, but I'm not sure, but I will check and confirm. So something around 16 or 17 controllers you can give in any cluster. That is based on the Red Hat PCS clustering solution I'm talking about. So inside controller you will find Red Hat PCS cluster. This PCS cluster has a limitation of maximum 17 or 16 hosts, exact I don't remember. The minimum which you should deploy is 3 for any commercial purpose, but if you want to do any kind of a testing or POC environment, then you can have 1 controller, because if 1 controller is down, then also you are not going to have any service impact, means those VMs are not so critical, so you can manually bring your controller up. But if you are working in a production environment, you don't want to do it manually, definitely if one of the controller is down and you want to have like another controller take the role, then you can deploy 3. You can ask me why 3, because that is the minimum suitable number for any clustering solution. This physical one is your undercloud. As a user you don't even know that undercloud do exist or not, but yes, the OpenStack administrator do know that yes, there is an undercloud. This is actually the entry gate to all the whole system and via CLI, because the GUI which you are connecting is coming to this controller on the controller virtual IP, and that is coming on the graphical mode depending on the privilege what you have. But if suppose administrator want to connect command line and want to perform more admin type of task, then administrator definitely prefer to go via undercloud. Usually controllers and compute IPs are never exposed to any outside world. They are restricted, no one is allowed to talk. Only undercloud is the considered as a gateway to the OpenStack environment. Okay, so this was about the repeat which I discussed. Means theoretically whatever we have discussed till now about OpenStack environment, we discussed in high level. This was the repeat of the complete session. Even I talked about like the deployment, that what are the steps you do in your physical deployment of your OpenStack. You have to first, so I started from very scratch. I mean, from layman's term, I started from day one. You purchase hardware, you from market, you mount your equipments in the data center, then you do network cabling, then you do power cabling, bring your power on to all the devices, perform some test, verify that there is no amber light glowing in any of the hardware equipment. If any amber light is glowing, that means that particular hardware is faulty, you should not use it. Then you do console configuration of your server, of your storage, of your switches. Then you install Ceph OpenStack software. So this is not OpenStack based, this is open source, another software which is clubbed with OpenStack. So you may get this software along with your OpenStack package from your R&D, but please remember, Ceph is not part of OpenStack, it is a separate project. So Ceph storage, what it is doing, it is going to provide you storage as a service. Then you are going to have first physical server, you are going to select as a Lifecycle Manager, triple deployment, that I informed earlier, that in Red Hat they call it as director. In OpenStack triple terminology, it is called as undercloud node. Then you install type 1 hypervisor in that particular undercloud node, the first node. You create a hypervisor type 1 hypervisor, which is KVM, preferred is KVM, you can use any other also. Then you create undercloud with the help of the VM image what is provided to you by your R&D. Then you configure UCVM to talk to all the physical devices in your OpenStack cluster. And there is a service in OpenStack, we call it as ironic service. So this is used for the bare metal provisioning of your physical servers. So all the physical server will be talking to undercloud node with the help of ironic service, which is part of your OpenStack. So I hope now you know why I called as OpenStack over OpenStack, because the first node itself is all-in-one OpenStack. It is, you can say, all-in-one OpenStack. All services of OpenStack, minimum mandatory services, are deployed in this, installed in this undercloud node. And those OpenStack services you are not going to use as a user. So if you want to launch your VM, you don't connect undercloud GUI, you don't do anything, you do everything from overcloud. Then why this undercloud is required? Because this OpenStack is going to take care of the whole OpenStack cluster. So that's the reason we call it as triple O. Now you can see first node you have installed with the ironic service. Then you see VM will now manage power on, power off all admin activities to its cluster. Fill the installation template. So nowadays the installation is automatic. You don't do all the tasks manually, that you install all services one by one, then you do configuration, then you do Nova or compute configuration manually, or you then define your PCS cluster. Everything is pre-installed. You just simply fill the template and let the installation take care of everything. So here you have Ansible, you have different frameworks, automation framework, which are helping in deploying your complete application, complete cluster automatically without minimal user intervention. So user need to just fill template and initiate the installation. Then on the background, the automation framework is going to take care of the complete installation. UC will trigger installation via heat. Heat is a method, bridge, you can say entry point from where you talk to your overcloud. So it act as a bridge. So it provide you route where OpenStack, your undercloud, can talk to your overcloud. So all the communication between undercloud and overcloud is done via heat stack. So heat is basically a stack. Now after that I mentioned that UC node or director node will act as an entry point for OpenStack administrator. So this was from day-to-day point of view, that it is going to act as a single point. Then all the logs of the complete cluster are saved to your undercloud node. Why it is done? Because suppose you want to integrate your OpenStack with any monitoring tool for logs purpose, then in that case you have to expose or make connection with all the controllers and compute. That means you are going to expose your whole OpenStack cluster. So what we do, usually we have a RSys log mechanism. So via RSys, all the compute and controller, they transfer all logs to the undercloud node, and from this undercloud node you can take all the logs. Even your troubleshooting logs, you can do troubleshooting from your undercloud. You don't need to go to any controller node or any compute node. See, you can go, it is not like you cannot go, but to make life easy for the system administrator, all the logs are available in your undercloud. HA proxy VIP of a controller will act as a dashboard IP. So from that, any user can log into the dashboard GUI. Even OpenStack administrator or login from dashboard GUI and perform most of the task. In today's time, most of the tasks, 80% of your day-to-day administration task is done with the help of OpenStack project, that we call it as OpenStack client tool. So there is a command called OpenStack, and then with that command you can do whatever update you want to do to your configuration. So for example, you want to update some setting in your configuration, your compute setting, or suppose you want to do any project quota expansion, or you want to create any volume for your project. Anything you can do, any administrator task you can do with that OpenStack client command. Same thing you can do from GUI also. So there are two ways to do it. It is depending on how much comfortable you are. Then pieces cluster is installed in case of multiple controller node. So as I mentioned, minimum 3 controller for production HA design. Then we have MariaDB Galera cluster. So MariaDB Galera cluster, what it is used, it is another open source DB clustering technology when you have multiple controllers. So the database of OpenStack, which is MariaDB, preferred one. You can use anything also, like you can use Cassandra or any database which you like. The database clustering database is installed on controller node. So controller node, 3 controller you are going to have, so 3 database. So there has to be some clustering which will ensure that database is on the same level of synchronization in all 3 nodes, all 3 DB nodes. So this MariaDB Galera cluster is going to take care of that particular synchronization of the database. Now I mentioned one important point that new release of OpenStack is using containerization in each of services instead of regular system services for faster deployment and efficient operation. That is containerization of OpenStack. See, nowadays you are hearing new technologies like containerization, Kubernetes, Docker, everything. But that is what you are offering to your customers. Like if you are an administrator, platform administrator, you are working in OpenStack or Kubernetes. For example, you are a Kubernetes administrator, then you are offering container services to your customers, clients. So client is going to come on your Kubernetes platform and going to deploy a pod. The pod is basically a container. So client is going to use your platform to deploy containers. But here if you see, I am talking about containerization of OpenStack. So how do you perceive this statement, containerization of OpenStack? One way of perceiving is that you can assume that OpenStack is offering container services. That is correct. Yes, OpenStack is also offering container services. Instead of Kubernetes, OpenStack is having its own orchestration. So it is offering you a way to manage containers on top of OpenStack. But I am talking about another dimension, that is containerization of OpenStack services. So what happens in OpenStack, we have services like Nova, Cinder, like correct, Keystone, Glance, all these services. These services are usually deployed as a service. So whenever you do systemctl service, you will see that particular service up or not. Suppose you want to do a health check of your OpenStack. How do you check? You simply see your Nova services. So how do you see Nova services? You see systemctl and then you check your status and then you see Nova services. So Nova has different components. Nova API, Nova computes, right? You remember Nova scheduler. So these things you can see from systemctl. Now what OpenStack is doing, they are containerizing these services. So nowadays these services are not installed as a system services, rather they are installed as a container. Means there is a container for each services. So don't go in more deeper details, because you may get confused that why I am telling that OpenStack is using containerization on bottom. See, as a services, yes, it is offering services, but it is also making their product more faster, because if you see containers, they are very fast to deploy and very you can say efficient deployment. Efficient deployment means, for example, if you deploy OpenStack and suppose due to any problem in your configuration, your service is not coming up, so you have to do a lot of troubleshooting and you have to spend time in that troubleshooting. But if you have a container, you don't do anything, you don't do even configuration, you simply launch your container and everything is plug and play. Means your OpenStack deployment is now very faster. Now let me talk about ETSI Mano architecture. That is the main agenda of today's session, because last class someone told me that are we going to talk about NFVI or NFVM? Okay, VNFM. Now let me tell you, this slide is specifically meant for telecom people. So telecom people who are working in telecom industry, so how this OpenStack or Kubernetes or any kind of a virtualization, VMware or any kind of a things, whatever these things are actually implemented in OpenStack with some framework. So this slide is for telecom people, yes, but other folks also, they can also enjoy and understand the how telecom is working or using the open source or cloud technology in their technologies. So telecom has created this framework, we call it as ETSI Mano architecture. Now what is this ETSI Mano architecture? It was basically founded in November 2012 by 7 of the world leading telecom network operators. ETSI ISG NFV become the home of network function virtualization. NFV, network function virtualization. So let me explain each of the terminology in very detail. So don't see this slide first. Let me first explain you some basic things before we start this slide. See, in telecom we have servers, right? We have servers, different applications, different type of servers. Like we have HLR, we have HSS, we have charging system, we have IMS. In IMS we have, IMS is basically a network, so we have different networks in that particular servers. So we have so many functions basically in the telecom network, and those networks itself are very huge server. So if I say like your charging SCP, if I say SCP, signaling control point, STP, signaling transfer point, so many terms, terminologies. So first initially there was some architecture to define the open networking telecom point codes. How do each device talk to each other? Now in today's modern time we are talking about ETSI Mano framework. This Mano framework is telling how telecom should use the virtualization. So this is the framework. So what happens? The very important thing for you to know is that NFV, network function virtualization. So what is NFV? Your server. So if you are working in HLR, what is NFV for you? HLR. If you are working in HSS, what is NFV for you? HSS. Simple. So go with the simple layman term. What is NFV? Network function virtualization, virtualized format of your HLR. So if you have your HLR deployed as a VM, it is NFV. If your HSS deployed as a VM, it is NFV. If you have any other application deployed as a virtual machine, it is an NFV. Now let me come to the diagram. So here you can see this is basically divided in two parts. On the right side you can see something called M. Here also you can see M. So I am breaking the code. So when I am saying that I am breaking the code, so I am telling you each terminology, each keyword used, what is the character resembling. So here you can see M, here also you can see M. So M stands for manager. Here if you see I stands for your resource, infrastructure. So what is VIM? Virtual Infrastructure Manager. Now when I say manager, so now you can correlate what exactly manager does. Manager is going to manage your virtual infrastructure. Infrastructure, when I say, means your actual data center. Data center means infrastructure as a service. So what is infrastructure as a service? OpenStack. OpenStack is the best example of NFVI. What is NFVI? Network function virtualization infrastructure. So suppose I am going to deploy HLR HSS on top of my OpenStack, then this OpenStack is going to be called as a NFVI, network function virtualization infrastructure, the infrastructure software on top of which my whole application is going to be deployed as a VM. So OpenStack is one example. You can have even VMware also. So I'm not separating VMware from OpenStack, but I will say OpenStack / VMware, because these two are the open source technologies available as a private mode for any telecom operator. You can even add Amazon also, AWS. You can add Microsoft Azure also. You can add Google GCP also. The virtualization layer, the services of the provider who are providing you the VM services. So that is which you are going to call it as your NFVI, network function virtualization infrastructure. And there is going to be a manager which we call it as virtual infrastructure manager. Manager is going to be responsible to manage this infrastructure. Now when I say OpenStack and VMware, then yes, there can be some manager which can manage this. But if you say AWS or any public platform, this manager will be helpless, because this manager cannot control internally how this whole infrastructure is running, right? You cannot put any of the controller or any of the compute node down in any AWS or any public platform. See, I am telling you just from my generic assumption that in any public platform you can have two type of node: physical servers which is deployed by those provider. One could be controller, one could be your actual node where your VMs are getting deployed. But I don't know the architecture of AWS, I don't know the architecture of Google or Azure, because they are exposing their services, they are not exposing their architecture. So you don't know how internally these platforms work. So this virtual infrastructure manager will not be more helpful, but yes, as a framework, if I say as a framework, this is the framework. You need to have a manager. That manager is going to take care of this infrastructure. Manager is going to now let's take an example of OpenStack. So in OpenStack, you remember I mentioned you under cloud node or director node, right? Or triple O. If you use triple O architecture, so that is the reason triple O is used in telecom. So many of you have asked me this question, that why or triple O is best as compared to other deployment architectures. So the answer is yes, because triple O is offering you a lifecycle manager which you can give this role. So it's not like you deploy a separate node and you call it as virtual infrastructure manager. No, you have this under cloud node, you have a director node, you have this UC node. You don't need to install any node separately. This is just your manager. See, this ETSI Mano framework is not asking you to install anything. It is just giving you the guideline how you should use any kind of a virtualization for your telecom network. So if you tell anyone that I'm using OpenStack, or if your company tells customer that I'm using OpenStack based deployment for my telecom products, now then the customer will ask you, okay, then are you following this ETSI Mano architecture? You will say yes. You don't need to install or provide any software or any extra node for this role. You can say that my director node, the triple O architecture, is already having this role. So this Vim role is given to the under cloud node. This NFVI is your over cloud. What do you mean by over cloud? Your compute and controller, where your whole infrastructure is going to run. Now you have another layer. So this is layer 1, L1. Now you have another layer called L2. What is L2? L2 is your VNF manager. What is VNF manager? VNF manager is your virtual network function manager. A node which is going to take care of the deployment of your VMs. So suppose in your environment you have to deploy, for example, you are deploying HLR or you are deploying HSS. You need to deploy 8 or 10 VMs of your complete setup. So in your application you have HLR A, HLR B, HLR C. I don't know. See, I'm just giving you the symbolic examples. So because I am not a HLR or HSS guy, but I'm just giving a symbolic example that if suppose you have HLR node A, HLR node B, HLR node C. Now this when you go and do deployment, so you don't need this virtual network function manager. You don't need it at all. You can simply go and connect this GUI of this dashboard and manually create n number of VMs, whatever you want, right? You can do it manually. You don't need to have anyone, but you have to do it manually. Means you have to do all the tasks. You need to connect OpenStack Dashboard, you need to connect VMware vSphere client, and you have to do all the tasks manually. And also you have to manage it manually, because if one of your VM is down, you have to connect your GUI and then perform the task, troubleshoot and fix that problem. Means starting from the day you created your VM till the day you delete your VM, means life cycle is managed manually if you do it manual task. But VNFM manager is giving you the functionality that no, you don't need to do anything manually. You just come to this VNF manager. VNF manager, there is some configuration, there is some information with this VNF manager for each node. So you have a logic embedded. That logic, for example, how to deploy HLR, how to deploy HSS, the logic is present. That logic is prepared by your R&D, product R&D. So product R&D is going to provide you a logic. That logic you deploy in your manager. This manager know how to deploy your HLR, but you need to tell separately that what is the IP you are going to provide to your infrastructure, because each environment will have separate IP, number of VMs, copies, how many copies you want to have, username, credential, basic information. These things you need to provide additionally on top of it. Then this manager is going to create a virtual machine. Means this manager is going to create a virtual machine on your OpenStack, and it is also going to manage the life cycle. Now you can ask me how it is going to connect the dashboard, right? It is not possible for any application to configure dashboard, because dashboard GUI are basically meant for humans. So me as a human, if you want to connect to OpenStack, what I will do, I will connect to the OpenStack GUI. But if any application want to talk to the OpenStack, definitely you will not be giving any such kind of interface. What interface you are going to provide? Heat stack. So this manager is going to create a stack with this NFVI stack. Means via heat service it is going to create a bridge, and then it is going to execute set of command to this NFVI, and then it is going to create a virtual machine on top of it. So the virtual machine, your HLR or HSS, will be deployed automatically without manual intervention. So suppose what is your installation guide? Installation guide is saying create a VM. After create a VM, assign network, connect storage, then do something, some IP configuration, then do something extra steps which I don't know, but I'm just taking as a generic one. So do those steps. So you have some 8 to 10 steps which you do manually. The logic, moment you embed logic in this manager is going to take care of everything. So from here you just simply say run or launch or deploy or instantiate anything, I don't know, like depending on the application this is deployed. So each company has different product for this. So Ericsson has different product, Nokia has different product, even your Huawei will be having some different product. Even you can have some third-party products also, which is going to play the role of VNFM. Now this VNFM is going to execute set of commands sequentially on this NFVI, and then this NFVI is going to create a virtual machine, and this is your final VM virtual machine. So in this way you do automatic deployment of your complete solution. So if you are an HLR person or HSS person, then you deploy your HLR HSS VMs using this VNFM manager. It is possible to deploy without this VNFM manager also. As I mentioned, this is just a guideline. It is not mandatory to go with this framework, but yes, it is a framework created for the effective utilization of the cloud technology in the telecom domain. So in telecom products, they follow this particular guideline. Okay, so now you see these two roles I explained you very clearly. Please let me know if you have any query in this, especially in these two layers, L1 and L2. Then I will move to the last layer, which is NFVO. But I'm not going to talk about NFVO until these two layers are clear to you. So do you have any query in this? No? Okay. So moving ahead, see the next top layer. So this is something hierarchy. This is your bottom layer, infrastructure manager. Yeah.
So this VNFM is the manager responsible for making all these VMs installation, managing the life cycle of the VM.
Yes.
Instantiation, automation, scaling, scale out, right?
Yes.
And Vim, what is this responsibility for this virtual infrastructure manager?
See, this Vim is basically to manage this NFVI, means your production OpenStack. Yes. So if you want to do scale out, you want to upgrade your OpenStack, or you want to expand your computer controller, or you want to scale in, then this can be done with the help of this virtual infrastructure manager. In OpenStack it is called as director node. In Mirantis it is called as control fuel node, I guess. I don't remember exactly, but yes, see, there's different name given by different vendors. So means it is just a role that can be played by anyone.
Understood. Just to manage the NFVI, to increase the computer or storage or capacity.
Yes, so everything is managed by this virtual infrastructure manager, and this is your infrastructure layer. This is your VNF manager. Whole deployment of your VNF you do it from here. Yes, so you don't connect to the OpenStack GUI, rather you just connect this VNF manager GUI, and you already have some catalog, you already have the logic present. If you don't have logic, you need to deploy your logic first, and then this is going to take care of your complete installation. So everything will be managed. It even does the health check also. Just for your information, this VNF manager is even capable to do health check of all the VMs in this project, especially this VNF which is running on top of it. So it has a stack. Yes.
In general, means the VNF for which we are working, we will have the tenant credentials and log in and perform the activity. Responsible only for the VNF we are managing.
Yes, it actually have a stack created with your NFVI. So with that stack, it can perform all the tasks. So this stack is heat stack, which is this NFVI is exposing to the manager. So with that help, it automatically connects. So you have some credential, your project credential file, RC file, RC file and IP. So it will automatically connect to your infrastructure and perform all the tasks. It can do health check for you. It can do scale in, scale out. If you need to expand your capacity, you can do it from the manager. So every time you don't need to go to the NFVI layer. So here you can see this is basically classification. This is your bottom classification of the layers, so infrastructure layer. Then this is your manager layer, where all the installation is done automatically without having any kind of a, like, you don't do anything. You simply upload logic and you just simply give instruction, and then this will do deployment. Now the top level in the ETSI Mano architecture is NFVO. What is NFVO? NFVO means Network Function Virtualization Orchestrator. Orchestration, you go with the keyword orchestrator. So orchestrator you have seen in Kubernetes also. Orchestrator you have seen in OpenStack also. What is orchestrator? Basically you manage. Means you don't do anything, you just simply give instruction that do this task, do this task. Means someone is already going to do task on behalf of you, just give instruction. So what is this NFVO? NFVO is basically a product. It is also a server or VM or any type of tool platform. This platform is having the capability that it give you something called catalog. Now what is catalog? Catalog means suppose you go in a restaurant. So what happens, waiter will come to you and it will show you some menu card. That menu card what you see from waiter is actually your catalog. You just simply say I want this particular dish or I want this particular dish. Then that waiter will go and waiter will tell the chef that please make this dish. Means that your actual kitchen where the people are working don't know who is the end customer and on what basis the customer is ordering. Customer is not even seeing that food, just simply the catalog menu that customer is being offered, and then customer is selecting from that. So this NFVO is similar kind of a product platform where you go and you simply select. You select what type of deployment you want to do. So for example, you want to deploy HLR, HSS, charging, IMS, all the network together without your manual intervention. So here what was that, you have to embed logic, then someone need to connect this VNF manager GUI and then go and click on the instantiate or trigger, or you want to terminate, you have to go and do terminate. Means someone need to perform some activity, means connect and then give instruction. This connect and give instruction role is now given to this NFVO. So what happened in NFVO, you have a single view of complete OSS BSS. So this whole OSS BSS portfolio, including your charging, billing, your means all the domains present in your telecom, everything you get a single view from outside. Now what customer is going to do, customer is going to connect this NFVO, going to select catalog, like I want to deploy a complete 5G network. Okay, 5G network, that is fine. How many nodes you want to have in HLR, how many nodes you want to have in your HSS, or how many IMS type of node you want to have, what type of, everything you select, you do tick. The moment you do tick means that you need it. So when you say you need it, what it is actually going to do, it is going to establish a connection and then it is going to send request to this VNF manager that we need to create some VMs, and it will tell you that you need to create HLR also, you need to create HSS also, you need to create another type of node also. Everything will be informed to the VNF manager. VNF manager will go and it will launch the VMs accordingly. So this particular orchestrator what you see is actually going to give command to, so if you see the hierarchy of giving instruction, so it goes from high to low. So NFVO is your catalog, you select what you want, you just select tick. Then NFVO is going to send instruction to VNF manager that VNF manager please deploy. So VNF manager is now going to connect this NFVI and it is going to create VMs based on the instruction it has received from the NFVO. So it will be having VNF A, which will be having VNFB. C means HLR, HSS, or different node. So it is going to deploy whole network automatically with the help of this command received from NFVO. This VNFM is going to execute because it already has all the logic. See, someone need to embed logic, that is true, because you cannot like say that okay, with the moment you are getting a command and then you are going to upload logic. No, you will upload logic, you will have this stack created, everything in place. NFVO will issue that command. So you don't connect an VNFM GUI, instead you connect this NFVO and then give command, and then everything will be deployed by this particular only. So this is your ETSI Mano architecture. See, it is very complicated network, architecture. If you see from first time, or if you see like if you just try to dig out, you will be getting it very confused that what type of terminology they are using. But I am explaining you in a very layman terms that this is your layer 1, which is having your actual OpenStack and VMware. Then you have a manager which is going to create a virtual machine. Then you are going to have an orchestrator, NFVO. This orchestrator is going to just simply issue command to your manager, and manager is going to deploy all the resources on top of this NFVI. So NFVI is actually platform which is providing you resource. VNF is your actual VM, and this VM creation command is coming from your NFVO. So NFVO is going to take care of complete VNF. So this is your ETSI Mano architecture. It's not a big one. You don't need to worry that you have to study each terminology one by one. You don't need to like memorize by heart. You just simply understand the layers, and rest everything is done automatically.
Krishna, what is this EM used for?
See, these are basically what happens that the moment you this VNFM command is coming, so it is going to manage, means it is not a VM, it is just an interface. Interface means, see what happens if it want to talk to your VNFM. So NFVO want to talk to VNFM. So this is something you see is just an interface. In this interface, it doesn't issue any command. So the actual communication will go via this VNFM EM. So VNFM EM, what you see is you can say a logical part which is used to provide service to NFVO. So how does NFVO know that what type of VNF is running on your top of your VNFM? Means this manager has deployed different type of VNF, A, B, C, D. Now how does this NFVO understand that what type of things you have deployed? So that's why this EM is there. So it is not any node, it is not a VM. It is not a VM, it is just a logical, you can say, inbox type.
It will take the data from the VNFM and reflect in the NFVO GUI.
Yes.
Achha.
So this is the architecture.
VNF and NVF both are same terminology, no?
Which one? VNF and NFV? See, it is just to make you confused. When you say VNF, virtual network function means what happens that in your applications, suppose as I said that you are deploying HLR. So HLR has two type of node, A and B. So VNF is similar set of VM. So suppose I have HLR A, and HLR A has 2 VM. So HLR A has 2 VM means it is VNF, virtual network function. HLR B has 2 VMs, that is function, that is second VNF. Now, but when you say whole HLR means HLR A and HLR B, that becomes your NFVI. Means the NFV function, when you say NFV, network function virtualization, that directly resemble your network function, means HLR. But HLR can internally have A node and B node. So when you say A node and B node, then you say VNF. So VNF is basically simple virtualization. Simple virtualization means you have 2 copy of one VM, that is VNF. So in that VNF you can have 3 copy, 4 copy, 5 copy of same set of VM. But if you combine, you take 2 set of VMs like VM A and VM B, then it becomes NFV. Okay.
Thank you.
Yes. So this is just to make you confused that NFV and VNFM, like NFV and VNF is same or not. Yes, it can be same. So suppose, let me take an example of your product. So I will not name your product, but the product which you are working is having one type of VM, right? So you have only one type of VM. So you deploy 2 copy of your VM. In that case, your VNF is equal to NFV. because you don't have any another set of your VM. So you can call NFV and VNF equal to. But if suppose someone else is deploying a VM application, and that application has two node, like DB node, application node. So the DB node is VNF1, application node is VNF2, and then whole combined you call it as NFV. So this is the best example I think I can give.
Okay.
Okay. Any other questions?
Same functionality VMs we can't refer to as NFV.
No, same functionality VMs you cannot call it as NFV, because you cannot have two HLR, same HLR VMs, and you call it as NFV1 and NFV2. NFV means HLR or HSS, means your complete whole server you are representing with NFV. But that server can have combination of different sub-servers, like it can have DB nodes, it can have application node, front-end node, different type of nodes. So the different type of nodes we call it as VNF. I hope it is clear to you.
Thank you.
Okay. Any other queries? Okay. See, theoretical I have covered all the parts in OpenStack. Now the only thing left is the practical lab. So I will try to have a class, but because next weekend I'm planning to have a lab session for Kubernetes, so it will not be possible to have two labs at the same time, like within 1 hour span. So first let me see when I can have a class for OpenStack. So theoretically I completed my OpenStack classes. Lab I will show you, give a demonstration how to create a lab in your laptop. So we'll do this maybe after next week. So I will send invite accordingly. So OpenStack next class, that will be, you can say, as a final class. So we will be going to have two more classes. One will be your final class, lab class, and one will be your question and answers. So if still have something, then we can discuss. So with this we will complete our OpenStack course. Any feedback if you have with respect to content, like you want to have more topics, so you can give feedback, and we will try to accumulate those topics also. Okay, so with this I complete today's session. If you have any question, then you can ask me. Feel free to ask me right now, or if you want to ask later, then you can send me message. Okay, so with this I complete today's session. So thank you everyone. I wish you all the best. So have a nice day.